Okay. We'll do physics tutorial first. Okay, here we go. Can you see this okay? Let's see. I'll turn the light off to be a little easier. Where's Ming? Now, do we need to see all the questions here? Because I think that was suggested.
Yes.
Yeah? Yes? Yes. Okay. How many were there? Five or six? Yeah. Okay, we'll get a start on them now. So if you can all take out your notes, we'll have a look at these. Right. Whoops. A projectile is launched horizontally. After launch, it takes 0.7 seconds to travel 50 meters to the target. Determine the speed, the horizontal speed, determine the vertical distance fallen. Okay, yeah, it's a little tricky. So, this is like the last example I did yesterday. You have your projectile, gets fired, but then it falls to hit a target here. You don't know the speed here. I'll just call it u. In fact, the only thing you do know is the time. And what else do you know? Yeah, which distance? Is it the horizontal for sure? Yeah. That's what the diagram looks like. What is the u? Okay, so should we look horizontally or vertically to figure out the u? Yeah, well, it has to be horizontal because the u is horizontal. So we have to use our triangle. Distance, speed, time. Yeah. So what does the u equal? 50 over 0.7, which sounds like, what is it? 71.4? Yeah, okay, good job then. Right, that's the u. Next we want this here, this s here. So should I look horizontally or vertically now? Vertically. U equals 0. V, don't know. A, minus 9.81 T. 0.7 S, don't know. S, yeah?
I don't get the V and the U, how it works.
Well, I don't know the V. I don't know the speed at the end here.
Okay.
And the U vertically is 0. It's not moving up or down at the beginning. It's only going horizontally. That's why it's 0. S equals ut plus a half a t squared. What is that, please? 2.4? Okay. before the projectile is launched, it accelerates uniformly from rest over a distance of 0.4, determine the acceleration. So what happens here is, it's almost like someone gives it a push to get it going, to give it a speed. What speed does he want to give it? 71.4. He gives it a push. So if we look at this little journey, what's the U? 0. The V? The A we don't know, the T we don't know, and the S they give us is 0.4. And they want to know the A. What will give me the A here easily? Yeah. V squared equals U squared plus 2AS. So the A is whatever 71.4 squared over 0.8 is. So what's the A here, please? Say again, Marwan? 6.3. Wait, it's a big number, is it? 6.3. 637. 2. Okay. Okay. No, didn't get that part. You got this one? Did you get this one?
First one?
Yeah. Did you get this one?
Yeah. If I use the formula, you're just a bit.
What happened to you, Ming? You're 10 minutes late. Right. Can you write that down? And we'll go on to the next one now. Yeah? Continue? Yeah? Continue? Okay. Right, let's have a look at the second question. Oh, I suppose I can check the answer by this. Okay. Number 2. A ball is projected at a velocity of 14 and an angle 35. Determine the vertical component. That's this one here. Yeah. So if that's 14 and that's 35, then this one here is 14 cos 35, and this one here is what we want. Yeah. 14 sine 35.
In this situation, 14 is what? Is it the initial velocity of the
Yeah, initial. Yeah. Can someone tell me actually on the calculator what is 14 sine? What is it? 8 point. Is the next digit an 8? What's the next digit, please?
0.
Oh, okay. Right. B. Determine the time taken for the ball to reach its maximum height. Okay. Am I looking horizontally or vertically? Vertically. The U?
14.
8. The V? 0. A? Minus 9.81. T? Don't know. S is what we want. Is it? T is what we want. Oh, and then S is what we want. What gives us the T? V equals U plus A T. So T is 8.03 over 9.81. So that's 0.819. Okay. And then C is the maximum height. Will we just say S equals U plus V over 2 times T, or whatever you want? So what do you get for the S then? What do you get for the S, please? So 29?
Which formula did you use?
S equals U plus V over 2 times T.
Times T,
Okay? Okay, so you can write that one down. That's the second one done. Yeah? Can I go on to number 3 now? Yeah, is that yes? Okay. Number 3. A basketball player releases the ball from a height of 1.65 meters above the ground. The ball has initial velocity of 14.3 at an angle of 40. So if I draw the situation here, the ball starts here. That is a distance of 1.65 meters. And then it's thrown at a speed of 14.3. Yep, it's the initial. And the angle here is 40. Yeah? This here and this here we can calculate. And it has to find the time taken for the ball to hit the ground. So am I looking horizontally or vertically? Vertically, isn't it? The U will be 14.3 sine 40, won't it? The vertical component. The V, we don't know. The A, yeah. The T is what we want, isn't it? And we do know the S. Minus 1.65. Yeah. S equal. Oh, can someone actually tell me what this is? 12.40? Yes? Agreed? No? 9.191. Okay. Yeah? S equals U T plus a half A T squared. So you have 4.905 T squared minus 9.191 T minus 1.65 equals 0. Using your calculator, what do we get for T? Mode, what did I say? Mode 53, was it, or something? And not the first answer, so then the second answer, not the minus answer. Yeah? And finally, they want this distance here. So, do I look horizontally or vertically? Horizontally. I'll just write it up here. If I use the triangle, they want the distance. Do we know the speed? We do. What is it? It's 14.3 cos 40. And do we know the time? 2.04. So if you just multiply these two together on the calculator, you can give me the range, please. Range equals 22.3 meters. Okay? Write that down if you need to. You wrote that down? Can I go to the next one? Wait, okay. Yeah? Yeah? Okay. Number 4. Now, one of the questions I removed, if you did it, that's fine. It was the one where it's thrown vertically upwards in a straight line. Yeah, well, I just changed it yesterday, so if you did it, it's fine. A ball is kicked horizontally off an 80-meter high cliff. At a velocity of 15. So that's here. It goes off like that. And this is 15 meters per second. Calculate the time taken for the ball to hit the ground. Fine. UVATS vertically. So what's the U? No, vertically. 0. V, don't know. A, minus 9.81. T, don't know. S, nearly, minus 80. 80 down. What would be the best way to get the T here? S equals UT plus a half A T squared. So T will be root 80 over 4.905. What is the T, please? Okay, so T is 4.03 seconds. 04 seconds. 04 seconds, okay. Got that? Next, they want the range. Yeah.
If like it was horizontal, like will you be 50?
If there was what?
If like it's horizontal, why are you? It shouldn't be 50.
But this here's vertical.
I know, like
Yeah.
just saying for instance,
Yeah.
if it was horizontal, will you be 50?
Oh, if I was looking at horizontal instead, yeah, you would be 15. Yeah.
They asked what was the time before the ball left the top of the building.
Yeah.
That's when you now use U as 15. Like if the question.
Oh, if it was before.
Yeah.
Yeah. Like in the last one.
Yes.
Yeah. But for horizontal, we don't need to use UVATS because horizontally there's no acceleration. So we're allowed to just use the triangle. So the distance we don't know. The speed we do know.
Sorry, I don't understand.
Yeah.
Horizontally there's no acceleration.
Yeah.
I remember you said it yesterday.
Yeah.
Horizontally there's
No acceleration. Yeah.
no to
4.04. All right, so just multiply these two together and we have our range. 16.16, is it?
60.
Huh? Oh, 15, sorry. What is it, 60?
Yeah.
Okay.
60.6.
Oh. Like that?
Yes.
Yeah. The result velocity, okay, so that's a typo. They meant to type the resultant velocity of the ball when it hits the ground. So we did one like this as well. They want the velocity when it hits the ground, and they want the direction and the magnitude, I would imagine. Yeah. So look, the good news is we're already half done. When the ball hits the ground, it has a horizontal and it has a vertical. We know one of these automatically already. Which one do we know? Yeah, we do. We know that this is 15. Do we know this? No, we have to calculate it. Well, but it's that one there is just going to be this number here, the V. So let me get the V here. V equals U plus A T. So if you multiply these two together, we can get the V. U plus AT. 39.6.
But the minus there.
And there's a minus, yeah. I'm not too worried about the minus for the moment because it'll disappear in a second because I'm going to square it in a moment. But you're right, it's downwards. But I kind of have the minus represented by having the arrow pointing down. Now, two things left to do. We need to get the magnitude. So how do we get the magnitude? Pythagoras. So if you don't mind, please give me the magnitude using Pythagoras. Square root 15 squared plus 39.6 squared. So 42.3 if I round it. And lastly, I need the theta here. So the direction. Tan inverse. Yeah, tan inverse 39.6 over 15 is what, please? What?
69.25.
So would it be 3 here?
Yes.
Downwards. Yeah, that's fine. So I'm representing the negative with the word down, and you're representing down with the symbol negative. It's the same thing. Yeah? What part? I know. The whole reason I record these things is so I don't have to repeat myself. How did I get the speed? Guys, how did I get the speed? What did I use to get the speed? Guys, please, I'm tired. How did I get the speed? What formula did I use to get the speed?
V is equals to
This speed here, come on guys, stop. Thank you.
Oh,
Pythagoras.
the resultant.
Pythagoras. Yeah? So the speed was equal to square root of what? 15 squared plus 39.6 squared.
Then also
Yeah, and then how did I get the theta?
tan inverse of that.
Tan inverse of 39.6 over 15.
Is it right if you write, let's say 35.6 over 15 and slash?
If you write what? 39.6. Tan inverse that?
I mean, like, if you write it like this instead of
That is so okay. Yes. You guys do listen to me when I'm talking, don't you?
Yeah, but then you're fast. Like you're fast. Yeah, actually fast.
Am I too fast or are you too
Yeah.
slow? It's a perspective thing, you know? It's a perspective thing.
You're fast.
Really?
You're fast.
You sure?
Like you go direct. You usually expect the formula and then but you just. It's a bit
Really?
fast actually. It's overwhelming.
I am assuming you know Pythagoras. Am I wrong?
No, not apart from Pythagoras. Pythagoras and trig ratio, there's nothing.
Okay.
It's
Well,
nothing
the
too special, but then
pace of the program is fast. It is fast. Now, it's all recorded. It's all recorded, so you can review it at your own speed. You know, YouTube has a feature where you can change the playback speed. Yeah? So if you want to do playback 0.5 speed, that's fine. Yeah? Or, if I'm too slow, you can do playback at double speed. Totally up to you. Yeah? Now, I'm not certain if you have projectiles fully understood. So what I'm going to do is I'm going to give you a question to try now. We'll see if you can get it. See, I have it here. Let's see.
there's actually one more for the
No, I removed that one. It's okay. Right, I'll be back in 1 second. I'm going to photocopy this for you. I have one question here. It was the projectile question that the September students did in their exam 2 weeks ago. Okay, it's an 8-mark question, which means you should be able to do it in 8 minutes. Okay, so I'm going to photocopy this. I want you to make sure you have all these written down. Okay, and then I'll give you this in 1 second. Yeah.
Yeah, my answer has some little different with, always have some little different with
That's fine. That's to do probably with the rounding.
Sorry, which one? The new question, which number 4?
Is it very? If it's only a little different, that's
because
fine.
I keep 6x every.
Ah, you're doing then you're smarter then. In the exam, they only expect you to keep 4. Yeah.
It's honestly too fast. See me, I'm used to they'll say this guy is supposed to look bad. You write it down. My guy is saying go to YouTube. YouTube don't get them still.
I go to YouTube.
But like he's too fast. Honestly, he see just like this thing straightforward. Yeah, I was like, and it was even like, yeah, you can put it on 0.5 back.
Right. Don't turn this over just yet, because I want to give you exactly 8 minutes for this. So just keep this down on your desk. Don't look at it just yet. Don't look at it just yet. Nobody listens to me. Move in, please, fellow. You guys are going to give me a heart attack or something. I don't know what. Move in back, please. Okay. So, just leave that down. I'll just get the stopwatch here. Yeah, because, you know, one thing the students say they find difficult about the exam is the time constraint. So they might say, oh, I can do the questions, but I couldn't do them quickly enough. Listen to me. A moment ago, you were saying that the pace is very fast. But in the exam, you have to do the questions quickly. If you ask students from past years, they will tell you one problem is the time. They can do the questions, but they can't do them quickly enough. Okay? So, this question here is 8 marks. Means it should take you 8 minutes to do this projectile question. So I'm going to time you 8 minutes and then we'll do the answer together. Let's see if you can do this. Right, off you go, 8 minutes. got it? Huh? Just write in your normal notes. You can just use your tablet. Yeah, you can keep that paper. I don't need it back. Stop. Time's up. If you're not finished, that means you did it too slowly. That's the 8 minutes up now. Okay? So let's have a look at the answer now. An object is thrown with a speed of 30 from the top of a building. The height of the building is 20. It's thrown with a speed of 30 at an angle of theta. Okay? The object hits the ground 4 seconds later. So it goes up and down like this. Yeah? This here is 30 sine theta, but we don't know the theta, do we? The first question is to find the theta. Fine. So, we'll start off with u equals 30 sine theta. V we don't know. A minus 9.81. T we do know. It's 4. And S we do know. Minus 20, isn't it? Yeah? S equals u t plus a half a t squared. Okay? So that means 4.905 times 16 minus 20 equals 120 sine theta. So if I divide by 120, I get sine theta equals, now let me just get my calculator out. We'll calculate it now. Well, some of you might have this fraction calculated. Do you? Does anyone have this fraction calculated? 0.4873. It repeats. Yeah. So that means that theta will equal sine inverse this number. What is it?
29.
So theta equals 29. Well, actually, you know what? I'll change this to 17 and then say theta is 29.2 degree is the answer. Okay? That's the first part. Is it? It was, where's it gone? Oh, I have it right here. Then B, here, they want the range. So, what do I use for the range? The triangle. Distance, speed, which I do know now, it's 30 cos 29.17, and the time, do I know the time? Is 4. So the range would be 120 cos 29.17. I've already done the 4 by multiplying the 30. So 105 meters. They're the two answers. Okay, that was 5 marks, and then that was 3 marks. Did you get 29.2?
Yeah, the first answer is 29.165.
Okay, so in the exam you must give it as 29.2.
Okay.
Yeah, and what about the range?
104, and then dot 78.
Okay, so again you must give it as 105 as the answer. Yeah. When the September students did this, I don't think any of them got it. This, of all the questions in section A, this was the worst question that was answered. The other questions, you know, a lot of students got them right, but it was just this one here that was the worst one. Yeah. Just before we do the maths, now, I'll just give you an example of the first, I'll give you the first question in the exam, okay? I can read it to you and you can give me the answer. And it's actually a lot of marks for what you have to do. You don't have to do much. So listen carefully and then tell me the answer on the calculator. The horizontal and vertical components are 20 and 30. Did you hear that? The horizontal and the vertical, that's 20 and 30. What is the magnitude and direction? The magnitude is 36.1 and the direction? No. Give me the answer for the exam. 56.3. Yeah? Above horizontal, yeah. Now. Yeah. Now. This was 5 marks. How many marks do you think that question was I just gave you? How many do you think? 1? 2? 4. 4 marks. Okay? So some questions are good, some questions are hard. This was obviously a good one. It was 4 marks. So that meant you had 4 minutes to do that. Okay? Yeah, that's my guideline. Yeah. The next question, it's not a calculation, you have to give examples. Give 2 examples of vectors and 2 examples of scalars. So 2 examples of vectors, velocity and displacement, fine. And 2 examples of scalars,
Time, mass.
time and mass. How many marks? 4. So those 2 parts were 8 marks. The same number of marks as this. Okay? So this is what I mean. Some of the questions are hard, some of the questions are easy. The difficulty varies by topic. Yeah? Yeah. Anything else you can do? Not just yet. Yeah, not just yet. So you can already do 16 marks. 8 and 8, which is 16% of the exam. Do you think about it like that? Oh, I haven't made the exam yet, so this is the end semester exam I'm talking about, not the midterm. Yeah. Okay. You have all the solutions on YouTube now. You also have this extra question I gave you, so that's a good practice question. Okay. I think projectiles is something that you have to practice. If you want, you could try those questions again by yourself and see if you can get the right answer. But if you're still having trouble, you can talk to me next week and I can give you more projectile questions if anyone is looking for more. Okay? But you should first try to do these again yourself to see if you can still do them. Maybe sometime this week. Alright, we'll have a look now at the maths. We'll close that. We'll close this. Right, so what was the last thing we did in maths? We did completing the square, was it? Was it? Yeah. We did page 14, didn't we? That's finished.